Okay, now we have to show that all these probabilities go to zero, or under which condition this probabilities goes to zero. The first is very simple. That is the event that the two sequences produced by the source are not typical. This we know is delta epsilon of n and pxy and goes to zero. Let's look at the second event. So if you look here, the second event is that the encoder 1 cannot find a sequence which is equal to the sequence emitted by the source. We look at the probability of event 2 and E1 complement. E1 complement means that the sequence is not jointly typical, and E2 means that we cannot find something like this. So E2 is here, that here, and together that the sequence xn is typical, because we know if it's jointly typical, then xn is also typical. So this follows directly by the jointly typicality. So that we can write as a sum over all typical sequences, pxxn, and the probability of E2 under the condition that xn is equal xn. If you look at this, we can write this probability here as a big N over W and V1, that xn of W1 and V1 is not equal to xn, because we assume that the encoder 1 do not find a W1 tilde and a V tilde that such that the entry in the codebook is equal to xn under the condition that xn is equal xn. But we know that we can remove the condition that xn is equal small xn, because all code words are statistical independent for all W and V1 tilde. We just constructed the codebook in this mode, in this way. Furthermore, the events in the intersection are mutual statistical independent, because xn of W1 tilde and V1 tilde are mutual statistical independent for all W1 tilde and V1 tilde. So we know that this all have the same probability, and we have in totally 2 to the n R1 plus R1 prime code words. So we have this probability to 2 to the n R1 plus R1 1 prime here for this probability here. And we want to have it small. This we can write as 1 minus the probability of xn to the 2 to the n R1 plus R1 prime. And here we use the same trick we used before, that 1 minus alpha is lesser equal E minus alpha. So we can estimate this here as E to the minus 2n of R1 plus R1 prime minus h of x times 1 plus epsilon, because we know that the probability that a sequence is typical is 2 to the n, 2 to the minus n times the entropy of x. If we insert this here, we get this expression. Now we want to have this expression small to get this expression small. So if we can make this small, so that this goes to 0, then we have that this probability goes to 0. Let's look at this. When does it go to 0? Okay, this drives to 0 by choosing large n, and if we choose R1 plus R1 prime bigger than hx plus 1 plus epsilon.